Good morning. My name is Leroy Sikkes. I'm a senior dev tech engineer working at NVIDIA Switzerland. The main office that I work at is Zurich, but I mostly work remote. Originally from the Netherlands, so if you guys know any Dutch, I mean, I can always speak to you in Dutch, but let's do this presentation in English. I'm mostly focused on performance optimization and graphics. It's a bit of both, but my main job is optimizing games. These are some of the games that I worked on, optimizing them and making sure that ray tracing worked as good as they could be. And well, the last one is a bit of an exception. That was a mobile game. So the presentation that was here before, like all that ARM stuff, that sounded all very, very familiar. Basically, I've done a presentation at GDC. I don't know if anyone here was at GDC. Can I see a show of hands if anyone was there? No? All right, so then probably nobody saw my talk. But basically, I gave a talk about like how we made the initial path tracing integration for Godot, and we did some basically some preliminary work to make that work, but it's still very much a work in progress. There's a lot of features that are still missing, but we do have some pretty promising results, and yeah, I just wanted to get it out to the community as fast as possible, just to kind of get reactions and see what people wanted to see. And now this is basically 1 month and 10 days later. One thing that we got, when I basically did the initial version, we only had Vulkan support, and that's important if you get the path tracing branch from here. You have to make sure that you set the rendering pipeline to Vulkan, because right now DirectX 12 support for ray tracing is still very much work in progress, and Skype is working on this to add DirectX 12 support basically to the whole engine. He's from the Godot Foundation, and he's just using this path tracer now to test all the new features for ray tracing. Then we also have shader execution reordering support. It's now it's still a work in progress. There's still some small issues with it, but it's pretty much there. It gives some quite nice speed ups, and yeah, it's just basically a checkbox that you can click. I will show it later in the live demo, but then it just gives you some free performance in most cases. We've also had requests to get native Linux support, because Streamline by default there's only a Windows version, and there's someone in the community called Fleeky. He basically added support for NGX, so then we can at least have DLSS and DLSS reconstruction in the Linux version directly, so you don't need to do it through Proton or something like that. I worked on adding fog support. While doing so, I actually also found some issues with SSR. If you have reflections, you don't see them with SSR in the reflections, so the reflections will not have fog, but your scene will have fog. In the path tracer, this is fixed. I added something called intersection shaders. So what you see here is, in the background you have a scene with about 100 million polygons. And then here you have an intersection shader, which is basically a mathematical way to describe a surface that can animate. So doing this with geometry would be almost impossible, because you then have to do like some marching cubes, and it's a really, really complex equation. It's called the Mandelbrot. But yeah, it's all working with all the denoisers. It's got motion vectors. It's yeah, you can kind of get something like this, which is otherwise very hard to do. Also, one thing that I worked on was high-res depth buffer reconstruction, and this is not just for path tracing. This is also, I don't know if you ever did any experimentation with FSR2, but if you use upscaling and you enable depth of field, you get some shimmering, and it's because the depth of field is using a low-res depth buffer. So basically this high-res depth buffer reconstruction basically gives a decent approximation that just makes your depth of field look good and it doesn't shimmer anymore. We also got John Logostini. He's done a lot of work just making some videos, making test scenes, just testing all the features on various scenes. Like I think we have the kitchen scene here with Sponza, a Minecraft scene, our Soul character demo, and he's done some Team Fortress 2 maps to basically see if the lighting is all working as expected. If you Google him on YouTube, you'll find his all his videos, because there's quite a few more. Like I couldn't fit them all on the slide. We also got Bonkahe and Kalinu. They've been doing a lot of testing and just figuring out if everything works correctly. And yeah, we found some issues also. And for example, MSA, we had some issues there. If you have the MSA enabled, it didn't work properly. And these guys were just testing it and seeing what's going on and fixing all these issues. And last but not least, we have Clay, who's been helping out, just overseeing all this work and giving some advice on certain things like motion vectors and whatnot. So that's a massive thanks for everyone helping. This is a Q&A session. I haven't really done a Q&A session, but I hope you guys brought any questions. Do you already have some questions initially? Yeah.
Hi, thanks. I love the work that you guys did. What were your reasons for changing to the bindless resource management, and what are your thoughts around that?
Right. So for path tracing, like the way path tracing works is that you shoot a ray into a scene, and this ray can hit any surface. And the problem is, once you can hit any surface, you can also hit any texture. So if you don't have bindless support, you basically cannot sample the textures, where you need to put everything in one single texture array, and it just gets very messy, right? You want it to automatically work. So basically the way the path tracer works is now for every frame, it just rebuilds the bindless bindings, and then that's what's used in the frame. And this could also be used in the future to optimize the rasterization path, make that faster. So it's that's a bit of a work in progress, but once the path tracer is more stable, then I might look at raster a little bit more also. Any more questions? All right. Okay, yeah, sure.
So with the path tracing approach, how would you best apply it in an XR context with the whole split view?
That's an interesting question. I think it's the thing with path tracing is what you can't do in a rasterizer. Right? With a rasterizer, you just have to take all the polygons and you draw them on the screen. And you do them one by one. But for a path tracer, you can actually select where you're going to shoot rays. So let's say you have two eyes. For your two eyes, you can first render one scene. You can then do depth reprojection. So basically, then you offset it a little bit for the other eye. But then you will have holes, right? And the thing is, once you know where those holes are, you could technically just only shoot rays there. So basically, you can get the secondary pass almost for free for the other eye if you're not too close to an object, right? Because then the whole screen needs to be re-rendered, but it could be really interesting. Like I haven't personally done any testing with it, but I have plenty of ideas. And also like things like you don't need to do all that distortion, because for a path tracer you can do the craziest lenses, right? It doesn't need to be like a flat plane like a rasterizer has to be, because you can shoot rays any way you want. So you can do things like fisheye and all kinds of cameras, technically. All right, any more questions? If not, then I'll try to swap to my machine here. We're going to try to do a live demo. Let's see. Okay. All right, so here's one of the scenes that I was talking about from John. It's an updated version of Sponza. And you can see the frame rate is quite good. It's like 340 FPS. And it's running, this was on a 5080 with a 550X AMD processor. I need to put the mics on. Thank you. All right. So here's the scene, and you can basically see some of the shadows are here. For example, they're quite nice and high res. And for example, if you go to the world environment here, then you can toggle the path tracing. And this is basically the raster with SDFGI enabled, SSIL, SSAO. But for path tracing, once you enable that, all those passes will disappear. SDFGI, SSIL, SSAO, because they're all just calculated natively by the path tracer. So you kind of lose a few passes, but in return you get a very you basically get all those effects that were just baked in the path tracing algorithm. So you don't need all these screen space effects anymore. And it's just like one unified pipeline. There's a few things that you can do. So you can toggle the denoiser here. This is basically the raw signal that goes into the denoiser. And right now DLSS is still enabled, but if you go to project settings and then you go to scaling 3D, then you can turn that off and you go to bilinear. This is basically the raw signal that goes into the path tracer. So DLSS RR takes that signal, and you can see it's quite noisy. But basically it figures out from that signal, it tries to figure out what is the ground truth there, what is the real signal like, and it tries to do that as fast as possible, because if you have a bad denoiser, then you will get temporal smearing and all the kind of artifacts that people associate with temporal algorithms. So the better the denoiser is, the better result you get. But the benefit of this is, for example, if you go to something like, let's say, let me turn the denoiser back on. And you have to enable DLSS in the options here. Now we're back. And in this scene, we have quite a few lights. And all these lights, they're shadowed. So if we go and disable path tracing, let's see. Oh, that's not good. Okay, now it's just taking a while. I was compiling shaders, and Godot doesn't have asynchronous compilation yet, so something else I need to fix at some point. Yeah, you can see it's actually slower, because the thing is, if it has to calculate, you can see here, for example, it was 6 milliseconds, and especially with rasterization, you have to render all the depth buffers, right? For every point light, you'll render a depth buffer. And for path tracing, you just don't need to do that. It basically flows from the algorithm itself. It just shoots a ray towards the light, and basically you get the shadows for free. So it's very, very, very good for if you have scenes with a ton of shadows, because you pretty much get them for free, and you have no shadowing artifacts because they can be very sharp. All the rays can be super precise. But it can also be a little bit like a cone, and then the denoiser will take care that it makes it nice soft shadows. In this scene, well, there's also quite a few, you see the AO stuff here, and that's very classic rasterizer, but with the path tracer, yeah, it's way more natural lighting, right? And also there's actually some normal map bugs that it actually also fixes. Let me show a new scene. I have a whole bunch. So if anyone has a question, thank you.
I'm so sorry. It's just I have so many questions.
No, it's just good.
Obviously, one of the things that people love about Godot is its approachability.
Yeah.
And what they particularly like about those separate passes there is a lot of them are used to sort of inject artistic intent and style into the game.
Yeah.
How do you see, without people having to get their hands like, elbow deep into the ray tracing code, injecting style into the path tracer approach?
Well, the thing is, you still have custom GLSL nodes. So basically, if you have the custom GLSL shaders, you can do a lot in there in terms of making sure that you kind of get the look that you want. For example, like normally in a path tracer, you don't have some some ambient light, right? Mm-hmm. And the thing is, maybe for your game, you kind of need some ambient light because there's just such dark scenes that you kind of want to just inject some ambient light there. And with the custom GLSL shaders, like the custom GLSL shaders, what I've been working on is that they transparently kind of emulate the rasterization pipeline, and you can then just write it as if it is a rasterized shader, and it will automatically load into the path tracer, and you can customize the whole thing. So that's where you have a lot of control. It also allows you to do things like in the fragment shader, for example, if you want to do something like normally for in a rasterizer, when you want to do, you need the depth texture, right? And you don't have that in a path tracer. So you have to kind of approach the problem a little bit differently. But what you can do in a path tracer, you can just fire a ray. You can basically fire a ray into basically the direction of where the camera is going. And then you can calculate depth that way. And you can even do things like you can find all the layers, which you can't do in a rasterizer, right? So there's a whole bunch of things that you can do. Technically, you could even still apply SSIO on top of the path tracer because the only thing that SSIO needs is a depth buffer. So if you like that kind of look, there's no reason why we couldn't bring it back. I mean, it is kind of like, I get what you're saying. Like, it is kind of like an artistic style, that darkening across everything. And if you really like that, I mean, you can bring it back. But
yeah, the challenge is that, like, I understand how I could go in and do all of that.
Yeah.
But, a lot of people love that world environment node and just all of the little dials. And even if they don't fully understand them, they can sort of go in and toggle them. And I remember we had this challenge at the start of the, not the current console cycle, but the previous console cycle.
Right.
When we started switching all of our art pipelines to physical-based rendering, a lot of the tricks that the artists were using started breaking because the lighting equations were like falling out. And it took us a long time to build like artist-friendly tooling for the PBR pipeline. So how do you see us making like artist-friendly tooling and just like your average indie-friendly tooling in Godot for a path tracing approach? Like, so they can make their game look different because they don't want it to look photoreal.
Well, one thing you were talking about, I think the lighting equation, I've been thinking about that you can swap that out. The problem is that's really complicated.
It's more about
Godot
like,
allows
how do we
you to
put
do
knobs
it, right?
and dials in?
Yeah, it allows you to do it. It's very flexible, but I haven't given it much thought yet. I think I have to kind of come back to you on that question. It's a very good question though. Like it's an interesting kind of way to think about it.
I have just a curious question. How does this like path tracing or the other like styles of rendering scale when you have like a lot of viewports you want to have?
That's the nice thing, because with path tracing, for example, you might not even need multiple viewports, because let's say you have something like, let's say Portal as an example, right? In Portal, they had to do all kinds of stencil masking and then mask that out and then re-render the scene from a different angle, and like you have to do all these kind of things to kind of get multiple viewports to work all right.
Yeah.
But with path tracing, you only pay for the pixels that are actually on screen. So if for example, that viewport is on screen, if you just shoot rays in a different area, for example, once you hit that surface, that's what I was saying about that custom GLSL node. Technically, you can even transport the ray to a different part of your level and then render parts there, right? So you don't pay the cost then to basically render your whole scene twice.
Yeah.
You can just do it that way. But you can still use viewports. But yeah, if you use a second viewport, then you're paying the cost for the denoiser twice, and you're paying, like, it has a significant cost.
Yeah.
Right? But it's similar with rasterization. It's also pretty expensive in general.
That live demo ran really well on a very beefy machine with...
But we tested it on 5050s and it works all right. You can even go back to, I think, like 2070s. So it scales quite well in general. And this was running without frame generation. So this was only the DLSS RR. So if you have like lower spec, like 2060s can even run it if you enable some frame generation, I think. So it scales quite well. I think like it's now 8 years of cards that that can run this.
You answered my question before I even asked.
Sure.
Hey, I wanted to ask, what is your ultimate goal with this? Is it like more a hobby project, or would you love to see it being merged to the main branch?
Yeah. I've talked to Clay about this, but there's quite a few features that we're still missing. Like there's things like skinning is just not working. So if you want to have characters, that's already, unless your game is only has robots, then yeah, you're gonna need skinning. So and blend shapes and all that kind of stuff I still have to implement. So it's really for like just giving an early preview now, and once all that we kind of settled, and later I'm going to come back in the presentation about this, but I really want to test this on as many games as possible before trying to put it in mainline, because then we have extensive testing, because making a new render is very complex, right? There's so many things that are different, and Godot has so many features that like matching all those features, every time I test a new scene, I find some other issue, that was some edge case that someone is using some kind of esoteric feature in the engine, and it's like, okay, that doesn't work, right? So in general, like this is kind of like an early preview for people to engage with and try it on their titles or their scenes or their whatever they want to try. And then once I have like a good coverage of everything, then I'll go back to Clay and like, hey, this is kind of like stable enough now. Can we just start the process, like getting it into mainline and like figuring out like what we need to do there to kind of get it over the finish line.
Hi there, quick question. When you were showing the demo with the leaves on the roof and using the raw signal, there was a bit of a spike, or like a periodic spike, that it was usually around 2 milliseconds and jumped off to 5 every few seconds. Is that some bit of work that's going on periodically under the hood?
It could be. The way temporal anti-aliasing works is it has a jitter pattern of 16 different kind of positions in the Morton encoding, and basically it cycles through that. Like it's like one of those. So basically, if you get the same pixel like flickering, that means you basically hit the same kind of like little jitter edge. But yeah, the denoiser takes care of that, right? It's,
but by a spike, I meant a performance spike.
Oh, performance spike.
Yeah, it went up to 5 milliseconds roughly.
Yeah, there is. Now, in general, the performance should be very stable. If there is some performance spiking, that might be a small little bug. When you get performance issues, is usually when path tracers are not that good at foliage. That's one of the hardest cases, because let's say a ray goes through a bunch of cards, right? Then what needs to happen is this ray goes through that card. It then needs to invoke the shader, figure out like, okay, did it get discarded, yes or no? And if it got discarded, it needs to restart the ray. So basically the GPU constantly has to resume and resume and resume. So that can get very expensive, because the way path tracing works, it just shoots rays everywhere randomly, right? So if you're unlucky and you hit everything to, like, for example, a tree, then you can get some deviation there. And actually, we have some optimizations for that. It's called OMMs. It's not in there yet, but I'm going to add it. But that basically allows to save one round trip, so that it bypasses the shader and it has some kind of mask to speed that up. So yeah, the performance optimizations, there's still a lot to be done. Like we just discovered some weird issue that might be in Godot in the first place, because the rasterizer, I think the depth pass can actually go a lot faster in Vulkan than it is right now. But I literally found that out like yesterday, so I didn't have time to figure it out because I already sent it to like Louis, and he was like also looking at it. I was a bit stumped, like, okay, what's going on here? We have to really do a deep dive here. But yeah, there's all kinds of interesting things we're finding, and I'm also basically bringing this to the Vulkan developer, basically the driver team, to figure out like what are all these performance glitches and can we do something about it. So in that sense, it's also very good for us to validate like the Vulkan backend.
Cool. Thank you very much.
Yeah.
Thanks for the demo. So what part of that can run on other brands like AMD or Intel?
Yeah, we're skipping through my slides a little bit, but I basically in one of my slides, we have a denoiser called NRD. And NRD works on Intel and AMD and pretty much any vendor because it's compute only. Because it doesn't use the tensor cores and it doesn't have an AI that can, because with TAA, the hardest part about like any kind of temporal anti-aliasing algorithm is figuring out when to throw away samples. When can you reuse samples and when you need to throw them away. And that decision can be very like hard to make. So the way people used to do it in compute is just having very clever heuristics, like maybe the depth value is a little bit different, or maybe the color is a little bit different. And now I need to discard the pixel, but it's kind of like you have to do it algorithmically. And what basically the deep learning part does is it can have like some more context based on real images and stuff to figure out like, okay, this is how to make it better, right? Sorry, what was the rest of your question?
It was just, will it run on AMD and Intel?
Right, and yeah, it will. But it's like you have to get a different denoiser, because the thing is we can't run DLSS RR on that kind of hardware because it needs like FP8 acceleration to run these deep learning kernels. Technically we could make it run, but your frame time is going to be 30 milliseconds or something just for running the denoiser. So that's why we have this other denoiser, and AMD also just came out with a drop-in replacement for DLSS RR, and that one will run on their latest hardware also. So there are definitely things that we're thinking about to get that in.
So I'm interested, obviously at the moment you're putting this all into the Forward Plus path.
Yeah.
You know, I might be biased sort of thinking about Dreams, and like we did a splat-based renderer there and everything.
Oh, nice.
But if someone was to go fill in on the path tracing approach, do you think putting everything into the Forward Plus approach is the right way to go? Or do you think there is maybe room for us to actually just go entirely on a new render path? Because obviously, as you mentioned, with the constraints of more targets and stuff, in some cases you don't want to necessarily implement all the features because they're not the best choices for the renderer. Right.
Yeah, it's when I started to make this integration, I was using a lot of parts from the Forward Plus renderer. I was still using, right now I'm still using the alpha pass for the Forward renderer, and it's not working correctly because the thing is you don't have then the GI information. You don't want to just run SDF GI just to get some GI on some alpha surfaces, right? So the more we can get into the path tracing paths natively, the better it's going to be. So I think in the future, because right now I'm not even doing the primary hits with Forward Plus, like it's full path traced, and because of that you can do all the path tracing nice benefits of like reordering the arrays and whatnot. But yes, I think so. Basically we can just already, I think, just cut out most of the code and put it in like a separate renderer. The main reason why I didn't do that is like once you switch also in Godot from renderer, then you have to restart the whole game. And with the Forward Plus thing and just having it as checkbox, you can add it as an option in your game, right? You can runtime toggle.
Sure, but in regards to if we want to get something like this into main, or we want to get new renderers, it just feels like a more achievable goal because, like, obviously, as you say, this works on cards that are like 8 years old, but there are a lot of people who, when we especially, unfortunately, I'm more on the mobile renderer because XR, we have these conversations like, well, we can't do X because mobile phone Y needs this.
Yeah.
And so like more and more I'm thinking about sort of splitting off into a specific XR related approach. Right. And I know on Dreams we made very specific decisions because certain things don't work well in a splat-based renderer. Like we didn't have what traditional style skinning, for example, just because it doesn't work great, but we were still able to do cool things. So yeah, if you were to go like whole hog into path tracing and we were to get that into main, it just feels like a more approachable thing. And I was just wondering, so you say it's just the alpha pass that you still need?
Right now, yes. Before I was also using motion vectors, basically the motion pass to just calculate motion vectors, but I just had a patch recently. I didn't show it in the slides, but that was also one of the other things that I added, that now the path tracer also knows about all the motion, and now it basically also calculates the motion vectors. And that's also important because the thing is for to get even higher quality reflections, and like if you have super metallic surfaces, that's very hard to do in a rasterizer, because then you have to start doing cube maps and all kinds of stuff. But in a path tracer, the hardest part is for the denoiser is that you then have two surfaces that move separately, right? You don't have one pass of motion vectors, you have multiple, because let's say your reflection moves slower than like the motion vector. So you can have two surfaces on one object. So basically we need to calculate specular motion vectors. And to do that, you basically need to do the whole motion vector calculation in the path tracer. Yeah.
I'm assuming that the tracing takes much more time than the denoising.
Depends.
And I'd be curious how much that is exactly, and how much extra performance can you squeeze out by just minimizing the number of rays before it completely starts to degenerate?
Right now you have, we're pretty much shooting for every single ray. You can select the amount of bounces that you want. So let's say you don't want any GI, then you just set the amount of bounces to 1 and you just get direct lighting pretty much. You still get the nice shadows, but you don't get GI. If you set it to 2, then for every pixel it'll start doing, at most 2, right? Because it can still decide to cut off a ray early because for some reason the material is black or something like that, right? Yeah, there's a bunch of things that we can do to improve performance. You can do things like, because the DLSS RR can really cope well with sparse signals. So for example, right now we're shooting a ray to the sun for every pixel. So for every time you basically fire a ray, we shoot a ray towards a light source, one of them. So basically it knows what light sources are in range of it, and then it selects a random light, and then it shoots a light ray at it. So the thing is now, so basically you're always going to pay that cost. But if you know, for example, I'm just going to have one sun or something, you can technically just shoot 1/4 of the rays to the sun and then boost the signal by 4x, and then the denoiser will take care of that. But the thing is, once you do that, the denoiser will have a harder time to figuring out your signal because it becomes more noisy, right? So it's, with a path tracer, you're kind of always fighting against noise. And that's kind of like always the trade-off. Like, do you shoot more rays here to get more detail there? Or do I have some clever way to shoot rays in a way that I can basically find the light? Because what a path tracer tries to do, it tries to find the light source, right? If it doesn't hit, for example, if you're in a building and you shoot a ray to the sun, that ray is wasted, right? Because it doesn't give you anything. It's just a black signal, and it's like there's nothing there. So it's, if you can shoot as many rays to some light sources as possible, that makes the thing faster, because then you can make the signal more sparse and you get more performance, right? And that's, there's a whole bunch of techniques that NVIDIA developed, and they're also online. Like I think Doom, the Dark Ages, had a great talk about like how to do that light sampling better. And I'm probably going to take a page from their book also to implement decals and maybe some of the light sampling, because it's now out in the open, so that will be great for MIT, and we can put it in there. But also, I'll take a look at our stuff where we kind of use basically we look at the whole image, every frame. And then if a ray found a light source, then basically you can bring all the rays around it, give it a hint like, okay, shoot a ray there, right? And that also gives a boost to the signal quality. And then you can basically then optimize further by then deteriorating the signal. So it's a bit of a balance, right? So it's like, yeah, there's definitely some trade-offs there, but yeah, there's a lot of things that you can do to tune a path tracer to make it faster or slower.
Thanks.
Sure.
Yeah, I have a question on the features kind of there that you're talking about, that you could, for example, tweak these things to reduce the noise and increase the noise in certain areas, and sort of with the viewport as well, where you could shoot rays and then direct them in different places in the scene.
Yeah.
And I mean, I think theoretically all these things are possible, but also like how feasible do you think it is to kind of incorporate these as features that you can tweak yourself in the engine? Or
I think that's going to be the challenge. Yeah, that's really what we have to think about. I mean, it's pretty much uncharted territory, because it's like nobody's really. I think in Unreal we have some path tracing, but the path tracer in there it's not as customizable. And they basically have all the same problems, right? And yeah, we really have to invent the future there. Like, what can we do there to make it easier? What can we figure out, like, to make it to useful? I mean, that's why I really want to have real games to figure out, like, hey, we have this problem. Like, what can we do there to make it easy for the artists to figure out, like, what can we do to make this to work right? But I think it's an iterative process. It's like hard to say, like, in advance, like, okay, this is going to be all the solutions. Like, we're figuring them out while we go, right?
Yeah. And how long do you think that that you have until you could like release what you have feature wise? Like, are you working now mostly on like fixing kind of bugs on what you've already made, or are you still like, is it lacking some critical feature from release? Yeah,
the skinning I think is one of the major ones, vertex skinning, and there's also things like what is expensive in a path tracer is not polygons, it is dynamic polygons. So if you have something like, for example, in the rasterizer, it's very cheap to just move a vertex around, right? In the vertex shader, you say like vertex plus this, and then that's it. Like, you can move your vertices all over the place. The thing is, for a path tracer, what you need to do is whenever you change your vertex position, you need to rebuild the whole acceleration structure for those vertices. So let's say you have 1,000 tufts of grass, and they all move around a little bit. Now that means that basically you have to calculate that motion for everything and then rebuild the BVH for that. So that really kind of like adds to the cost. So yeah, there's a couple of other different trade-offs that you have to do there and figure out. Like, you have to do a little bit of different things. I have a lot of ideas to make that actually faster. Because for example, you can do things like, instead of moving the vertex, what if you just make the vertex a little bit bigger, but you just move the texture around? Like, so you have to kind of have a bit of a different mindset, right, to these things.
So, sort of two quick questions. One quick and one not so quick. The first quick question is, how much customizability in regards to sort of training the denoiser is there? For instance, if someone is going for a strongly different art style, I'm out of date with the NVIDIA denoiser. How much can you tune its approach?
Yeah, that's still an open problem. Like, I'm still talking to all the guys in the deep learning teams that train this thing, and what I want to do is I want to actually add to Godot, and that no other engine has this right now, but I want to put in Godot that we basically have all the things needed, that it can output all the data that you need for training DLSS, and then if someone has a problem, that they can send it to me, and I can then give it to the training data, and that they will put it in the next model and get a new model. I think that's kind of the idea.
So you're thinking about it being released with a driver rather than a per...
No, it's a separate DLL basically. So then it's a streamlined DLL, and then you can pick and choose the one that works best for your game, right?
Brilliant.
Yeah.
And then as you say, one of the big problems with path tracing is that rebuilding of the spatial structure stuff.
Yeah.
In that context, how applicable do you think volumetrics are regards to a traditional polygonal flow? Because
as in SDFs or like
not just SDFs, but also thinking about like the NERFs and sparse voxel grids and other approaches there in regards to trying to figure out what works well with the path tracer and sort of data structures, because prior to our current Excel work, like all of my work's been with volumetrics, and all of our stuff was moving towards path tracing. We didn't ever pull the trigger fully on it, but like we were losing so much of our frame time to dual contouring or some other traditional pipeline.
Right. I think actually Teardown had a great talk on this at the graphics programming conference in Breda. I was there last year. I think you can find it online, but they were using intersection shaders. It's also now fully gone to hardware ray tracing, and they use intersection shaders now to basically then have like small little boxes around like voxel volumes, and then that way they can still make it sparse. But then you still get some acceleration from the GPU, because it's always in two layers. You have the top level acceleration structure, which basically contains all your instances, and you have the bottom level acceleration structure. So for like volumetric rendering, you don't really use that bottom level acceleration structure, because at that point it's going to be a custom defined shader, right? And that was the thing that I showed here with the Mandelbob. Instead of there I basically it's like an SDF fractal march, but if you just have like a 3D texture or something, then you can do some volume ray marching or do some voxels or do anything you like there, but you still get some TLAS acceleration. So it's kind of like a hybrid then.
Yeah, because we were like, without breaking NDAs and stuff, we were thinking a lot about this in regards to, as I say, Dreams Render, because I don't know how familiar you are with it. But
Alex Evans, right, worked on that.
Yeah,
I worked on NVIDIA for a while.
I remember we went off to do the instant and all that stuff. Because obviously, like at the, I'm pretty sure this is in his SIGGRAPH talk, but at the low level, we had like our little chunks that like mapped quite well. And obviously, we were trying to figure out how to move to the new path tracing stuff on the PS5 stuff.
Yeah, I think the Teardown talk would be a good thing to watch, because they went super in detail on this stuff.
Thank you so much.
Yeah. Right. How much time do we have left, actually? Like 8 minutes?
Hello. Slightly specific thing, but how would this whole process interact with things like, with specifically layer transparency? Because that's pretty finicky to get working on forward rendering, even because like if you have like glass that distorts things and needs to see other transparent things, you have to set up like other viewports to buffer things so that other transparent things don't disappear behind it. So how would that interact with this approach?
Yeah, that's the nice thing about path tracing. You can just continue your array. So you can even do things like colored shadows. It's not, I wouldn't say it's free, because there's a couple of optimizations that you can do if you don't have colored shadows. But I'm thinking of basically making some kind of checkbox that you can have like advanced shadowing for transparency, and then you'll just get them for free pretty much. Like they'll be included. I think there's going to be like a 10% performance cost on the whole, but yeah, it's very doable. You can, I think in Minecraft RTX we also had some demos there, like where you can place some glass blocks that then have colored blocks, and then you get a colored shadow, and like it goes through multiple transparent layers, and then a water, and then so it will all work. It's just not supported yet. So that's also one feature that I really want to add.
What about specifically things like refraction and distortion? So you have like a crystal ball behind that will warp things at the edges.
Mirrors and distortions are very good to do. The hard case that we found right now for denoisers, especially the SRR, is just a piece of glass. Because the problem with glass is you can have a reflection, and you have the surface below it. And what the denoiser wants, it wants to kind of know what's underneath, what's kind of like the stable signal, like what's your albedo, what's your normal map. And at that point, you actually have two surfaces, right? So then you kind of have to choose, like, what surface am I going to send to the denoiser? And yeah, that's where the complexity lies. But yeah, that's an active topic of research. We have some ways to kind of get around that. But they're not without any trade-offs. Like, yeah, there's no free lunch. Like, I have some ideas to handle that even better, but there are performance costs to it. So it really depends on kind of your game, like how well you need that feature. Like, if that's going to be the whole part about the game, then yes, you probably want to pay some penalty to get better quality on that. But I think for most cases it works all right, and we can get some heuristics that do it right for the most cases. But yeah, it's a bit of a trade-off.
All right, thank you.
Sure. All right. More questions? No. Okay. This is one of the scenes that I was trying. Thank you. Yeah, it takes a little bit for these big scenes. Like, Godot was not really designed for it yet. I think at some point I'll have to take a look at this. Yeah. So this is a scene. You can see the amount of primitives down there at the bottom. Like, it's 165 million polygons. It's running in 200 FPS right now. And if we actually run it without path tracing, it looks something like this. And it runs at 120 FPS. So the thing is, this scene doesn't have any LEDs. Well, it does have some LEDs because Godot generates LEDs, but LEDs don't really work for trees. Like, you have to really do like your card optimizations. This is a scene from the Korea Cultural Information Agency. It's like a free asset, but yeah, they got a lot of complexity in here. One of the nice things, for example, here is that you really get like super high detailed diffuse lighting on these pedals, for example, because there's just not enough precision in SDFGI, right? It's very coarse, so it just can't capture all those details of all the lighting. But for path tracer, it can work at any scale. So if you're super close to an object, it still gets right diffuse illumination and all that stuff, because it's invariant to all that kind of stuff, where you don't have any probes that basically can make it a problem. The thing is, like, for example, these trees are not animating, and that's really one of the challenges still. Like what I was saying, like, then you have to pay the BVH costs. So at that point, we're still going to need things like LEDs again, and like having some clever ways to kind of for trees. We just had a presentation on this from Martin Stitch at GDC. You can find it online if you're interested, where we basically have a scene of like 1 million trees, and they can all animate and all this kind of stuff. So we did a lot of clever trickery to kind of make that work right. I'm hoping I can actually also bring that to Godot, so that we'll have high quality foliage, and you just don't have to think about all this stuff. Yeah, it's a work in progress. But yeah, you get some pretty nice details on everything. Like, you get soft shadows. I think actually here, this might crash. I haven't tried it. All right, now it's good. Here's the mandel bulb that I was showing before. And it's like a very complex object. So I can show a little bit like how this shader thing works, right? So this glitching is basically the buffers are uninitialized for the first frame. So that's why you get this very funky geometry. It's only happening on Vulkan because it allows for uninitialized buffers. But yeah, it's something I need to fix also, but it'll get there. Here you can see the shader. So basically the workflow is just you just get the same kind of shader editor as always, right? And here you define the SDF for the Mandelbrot. That's basically the sign distance function that tells you how close am I to the Mandelbrot at any given position in space. And then it iterates. It's like a very, I think in this case I do like 14 steps like to iterate to find the position. And there's a whole bunch of things that you need to do. You need to calculate the normals because you need to fill in all the buffers that you need for DLSS RR, right? So you need that diffuse albedo map. You need the motion vectors. You need basically all the kind of things that the denoiser wants. And once you can supply all those things, you can then write this intersection shader, and then that does the ray marching, and then we'll find you the surface. So this is kind of going into that whole super customizable thing like this. This allows you some objects that, like with a rasterizer, it's very, very difficult to do, and you can do things like animated boxes or like yeah, basically any kind of SDF that you want, right? But it's like you have to really put some effort in to kind of make that work. And I'm hoping that people will find some creative things to do with this and maybe turn them into some Godot modules that we can put online and like, hey, here's some cool thing. Just put it in your scene, and then we have something cool, right? But yeah, you can see that it just gets shadows. It's all intertwined correctly with the rest of the world, so you can kind of like mix and match normal geometry with procedural geometry. And I'm also thinking like maybe you can even do something like procedural graphs and go in that direction, like procedural trees or something like that, because then you don't have to rebuild this BVH, and you can kind of get speed ups that way, and maybe even more detail. Because let's say you want a sphere that's perfect, like it doesn't have any edges. You can do it with like 20 lines of code. So yeah. I think we have to stop soon. I have some more slides, but I think that's it was more like a question round after this. And yeah, I'd like to acknowledge all these. Well, I have to switch back, I guess, real quick. I'd like to acknowledge all these people for really helping out with this whole endeavor. Yeah, there's a lot of people already involved and making great contributions, and I appreciate all of them. And yeah, if you wanna join us in like these conversations and figure out what's going on, this is where you can find us. Like it's a little bit hidden because we have a discussion. So you have to kind of go to the Godot rendering, and then you have to type NV Pathtracer, and then you'll find Clay's big discussion with 3,000 messages in there where we're discussing all this stuff. And yeah, I'm really looking for people that are working on cutting edge, like nice indie 3D games with, and they want to bring their graphics to the next level. I'm willing to help everyone. So if you try it and it doesn't work, like just contact me, and I'll try to help you out any way I can. Yeah, the more we can get this thing tested, the faster we can get it to mainline and get it in the hands of everybody. And also, even if you're not even interested in this path tracing, you can still look at it and try it with your game and use DLSS, because then maybe you have like some better denoising options also. So it's an easy way to get some benefit from this work also. I'm usually on Rocket Chat, or you can also add me on Discord if you find me there with that username. All right, to be continued.